All right, we're rolling. Please stand. And let us pray. In the name of the Father, and of the Son, and of the Holy Spirit. Amen. Remember, O most gracious Virgin Mary, that never was it known that anyone who fled to thy protection, implored thy help, or sought thine intercession, was left unaided. Inspired by this confidence, I fly unto thee, O Virgin of Virgins, my Mother. To thee do I come, before thee I stand, sinful and sorrowful. O Mother of the Word incarnate, despise now my petitions, but in thy mercy hear and answer me. Amen. In the name of the Father, the Son, and the Holy Spirit. Excuse me. Please take out your homework 3B as in Baker. That was a book assignments. Page 100 thereabouts, 98, 99, 100. Actually, that's where the reading starts, I think. Yeah, so it's on page 103. It was 1 through 19 odd, and then 22 and 23. Okay, yeah, that would be yeah. That would be for tomorrow. Okay.
How did you know? It's only like the thing I say the most. That's what you might have some.
Grab your favorite red writing utensil. Have it ready. Let me get this on screen so the video people can see me. And here we go. Everybody sets. See what we got. Number 1. These should be in interval notation. I'm actually going to try and translate these. There should be two brackets. So round bracket, negative infinity to negative 4, round bracket, union, and then round bracket 3, comma, infinity, close bracket, round bracket. Everybody okay now? Number 3. Should see, oh my goodness. There we go. There's a round bracket 1, comma 2, round bracket, then union, round bracket 4, comma, infinity. Number 5. Depending on how you did, there are several ways you could have done this. The first bracket is round bracket negative infinity, comma 4. I know, I take that back. Round bracket infinity, comma, negative infinity, comma 2. Then union, round bracket 2, comma 3, round bracket. And then one more union, 3, comma, infinity. If you didn't get those last two, if anybody happens to have just from infinity, negative infinity to 4, I'll let it go for now, but I'll explain how that worked. So ask about number 5 if there was anything mysterious on that. Number 7, there's one interval, round bracket, negative 3, comma 5, round bracket. And make sure you do the x belongs to before that. Number 9, round bracket, negative infinity, comma, negative 1, square bracket, then union, square bracket, 3 over 2, comma, infinity. Any repeats up there? Number 11, one interval, -7/2, and square bracket, comma, 1 square bracket. Number 13, there are two intervals, round bracket, -∞, comma, -5, round bracket. Union, round bracket, ~5, comma, infinity. Number 15, there's one bracket, round bracket 2, comma, infinity. Number 17, let's see, make sure I don't overshoot. There are two. First one is round bracket, -∞, comma, -3, round bracket. Union, round bracket 1, comma 2, round bracket. Number 19, there are two intervals, round bracket -∞, comma -2, round bracket. Union, round bracket 1/2, comma 1, round bracket. Any repeats up to number 19?
Number 19.
No problem. The first one is from -∞ to -2, round brackets for both. And the other one is from 1/2 to 1, round brackets for both. Sure. Any other repeats? Yeah.
Number 13.
13. From -∞ to -5, radical 5, and from positive radical 5 to infinity. Any other repeats, 1 through 19? Yeah. Number 22, excuse me. Let me see, there are two intervals, from negative radical 3 to negative radical 2, round brackets, and from positive radical 2 to positive radical 3, round brackets, with a union between.
Could you repeat that?
Yeah, from negative radical 3 to negative radical 2, round brackets, and from positive radical 2 to positive radical 3, round brackets. Okay. And number 23, there are two intervals, from -∞ to -1, round brackets everywhere, and from 1 to infinity, round brackets everywhere. And it repeats on the whole thing. Yeah.
Could you pick number 1?
Number 1 was from -∞ to -4, and from 3 to infinity. The other? Yeah.
15.
15. From 2 to infinity, round brackets. Any other repeats? Okay, don't look through reading glasses when you're bending down. That was weird. All right. Questions? Any of those you want to see dug through? Yeah.
Number 5.
Number 5. Let's see what it is. X minus 4, x minus 2 squared. X minus 3 squared. This one is a little on the tricky side, I'll show you. There's good news and bad news. The good news is it's already factored. So you don't have to do the synthetic division, blah, blah, blah. Let's run plus or minus notation on it. I've got roots. There are no vertical asymptotes and no holes because we're not dividing by anything. So there are 5 roots in here. There's a root at x equals 4. There is a double root at x equals 2. And then there's a double root at x equals 3. Whoops. So it should like this. It should look like, wow, that wasn't even English. It should look like this. So double root at 2, double root at 3, single root at 4. And here are the regions. Let's get region A, B, C, D. Now, they want the regions that are less than 0. I'm just going to pick x equals 0 because it's easy. And then it looks like this. Single parentheses, parentheses squared, parentheses squared. Plug in a 0 and I get negative, negative, negative. How many total negatives? Take a look at there. How many total negatives in this whole mass? Go ahead. 5. See that? These two negatives make positive, these two negatives make positive, and there's one negative left. So this region is negative. So A is negative. What about over a double root? Awesome. Still negative, it doesn't switch. How about over a double root, Blaze? Stays the same. And then how about this while you're at it? That switches because it's a single root. Does that make sense? Now, they wanted all the regions that are less than 0. Where are they less than 0? Here, here, here. Question. Should I include this point? Should I include x equals 2? Is that part of the solution? Yeah. Normally you would. It is safe to give. There's one reason why we wouldn't. Can we see it? They didn't ask for the ends. There's no equal. They just wanted the less than, not equal. So this is one way it's kind of deceptive. It looks like, yeah, I can give it to them. They're not asking for it though. So you just use this region, this region, this region, and you skip the endpoints. So it should look like this. X belongs to, from negative infinity to 2, union, 2 to 3, union, 3 to 4. Did it? Oh, I might have misread that the first time. Let me see. Did I say from 3 to infinity the first time? Sorry. From 3 to 4. My bad. If that fixes your answer, good, and I apologize. Any others you want to say? Yeah.
13.
13. X to the 4th minus 3x cubed minus 10. What's a cube? Squared. 3x squared minus 10. And is that greater than 0? Okay. This is number 13. Question. Does this factor? What do you think? Who's feeling brave? Go. It does. How? It's a tiny bit strange. What does it split into?
X squared.
Yeah, x squared, x squared. This is actually, go ahead.
Minus 5 plus 2.
Right, it's an unfoil problem. It's going to be two numbers that add up to negative 3 but multiply to be negative 10. So it's going to be minus 5 plus 3. Does that make sense? The 2. That's our math. Everybody okay? So they add up to negative 3 multiplied by negative 10. How do you solve this? Does this factor again? If we were in first year algebra, I would say no. Even if we were in second year algebra, probably not. In pre-calc, there may be a way to do this, and it's actually easier than you think. Because part of it's a little on the icky side. Can we see it? What pattern does that look like?
It would be like x plus radical 5, x minus radical 5.
X plus radical 5, x minus radical 5. That's the difference of two squares. Right. 5 is not a very good square, but if you can rip it apart into square roots, you can use it. And we have done that in pre-calc. Oh, dude, what's up with this? Does this factor? No. Why not? What's wrong? Why not difference of two squares? Good.
Because it's addition sign, not a subtraction sign.
Right. It's a sum of two squares, and that's always going to be prime. By the way, if you set these equal to 0, you're going to get imaginary numbers. It's like square root of 2 times I. So I'm just going to put this here. This has imaginary roots. So we don't have to graph them on our plus minus notation. They don't exist, so you don't have to draw a picture of them. There are two, and only two. There's a negative radical 5 and a positive radical 5, and there's single roots. So we've got regions A, B, C. I'm gonna pick 0 again. Well, that's not 0. I'm gonna pick 0. And then Y looks like this. Remember, you do need to use this for your pluses and minuses. Plug in a 0 here, and it should be positive. Plug in a 0 here, and it should be negative. Plug in a 0 here, and it should be positive. That makes this region negative. Single root will switch the sign. Single root would switch the sign. They wanted regions that were above 0, which is positive. So we want regions A and C. So you'd have x belongs to from negative infinity to negative radical 5. Round brackets, because they didn't ask for the endpoints. If this had been greater than or equal to, I would have put a square bracket there, because they would have been asking for it. Then union, positive radical 5, comma, infinity for region C. Does that make sense? Next. Any other answer you want to see? If there are any of these that you would not feel comfortable doing on a test, go ahead and ask a question on this. How are these going? Easy, hard, medium? None stressful, hopefully? Any other questions? Going once. Twice. Thrice. All right, go ahead and put that away. The next section, there's a worksheet that's going to be due tomorrow. It's largely the same sort of thing. If there are any things that are sticky, I'll be happy to go through them. But I want to give you a few notes on the very first section, which is going to be homework 3A. That's the one that's going to be due on Thursday. A few things. Some of them are review way back in first year algebra, and you haven't had it for a long time. And the second thing is a little on the weird side, but we've seen an example or two of it. Let's take a look. Solve. Yeah, let's do this. Try that. Negative 5x plus 1, all divided by negative 8, with plus 7 afterward, equal, or is less than or equal to 5. And I'd like you to solve that for x. Now, there are two ways to do this. I'm going to show you, I'll show you both. First question, how many species of x do you see in this problem? 10. 1. What are you allowed to do if you have only one species of x? What method can work for solving? Back on the quadratic set, yeah. Algebra. Basic algebra on both sides. In other words, if there's only one species of x, you can add things to both sides, subtract things to both sides, square root both sides, divide both sides, blah, 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 blah. And it should solve. So we should be able to solve with algebra. One little caution though. What that is. Can anybody name the 4 things that flip inequality signs when you do it on both sides? Go. Dividing or multiplying by negative. Good. So the things that will flip inequality signs, there are 4 of them. The first is multiply or divide by a negative number? What's another thing? You remember? Yeah.
Absolute value.
Something about absolute value. Splitting an absolute value. Yeah. Getting rid of an absolute value. Splitting an absolute value will give you two answers. What kind? Go. Positive or negative. Guess which one goofs up your answer? The negative. I put parentheses, the negative side only. Ringing some bells from previous years? Yeah, well, what's another one? Yeah. Square rooting. How many answers does that give you?
2.
What kind?
Positive and negative.
Which one goofs it up?
Negative does.
Yeah. Square rooting, negative side only. And last year, or the year before, whenever you had me, there was a fourth thing, which we did not cover last year, but we are going to touch this year. You remember? There's one more thing that will flip inequality signs. What's that? Reciprocals. Taking the reciprocal of both sides. That you don't need to do negative side only, because there isn't a negative side. But there's a bit of a caution. This needs the answer equal to 0 and use plus minus notation. That's the only way to do a reciprocal problem. It looks really, really easy when you first run into it in first year algebra. We'll run into it. I'll give you an example of that after we try this one. For now, somebody attack this. Megan, what would you get rid of first? If I'm trying to get x by itself.
The 7.
Yeah, how?
Subtract 7.
Subtract 7. Question, does that flip the sign?
No.
No, it's not one of the four things. Adding and subtracting will never flip the sign. So cancel. So we have, I'll just write this out. Negative 5x plus 1 over negative 8 is less than or equal to what?
Negative 2.
Negative 2. Good. Keep going, back up.
We multiply by both sides.
Yeah, multiply both sides by negative 8. I use parentheses to do that. Question, will that flip the sign?
Yeah.
Yes. Multiplying or dividing by a negative will flip the sign over. Now these will cancel, and you have negative 5x plus 1. All of a sudden, this flips. And then it's equal to what? What's the answer?
16.
Positive 16, correct. Does that make sense? Nate, take over. Take 2 of them. Get rid of next. The 1, how?
You subtract it.
Yeah, does that flip the sign?
No.
No. What do you have so far?
Negative 5x
Oh.
is greater than or equal to
15. Keep going.
Divide by negative 5.
Divide by negative 5. Does that flip the sign?
Yes.
Yes. What do you get?
X is less than or equal to negative 4.
Correct. And that is your final solution. If you put this in interval notation, can somebody give it to me? X belongs to what? If it's less than or equal to negative 3, what does that look like interval-wise? Blaise, go.
Like negative infinity,
Yeah, from negative infinity up to what?
negative 3.
Right. Round or square on infinity?
Round.
And how about on negative 3?
Square.
Square. Good. Because they wanted to include negative 3. Does that make sense? Everybody okay on that one? Right. Now keep in mind the list of 4 things that flip inequality signs. Multiplying or dividing by a negative. Splitting an absolute value. We'll cover that a little later. Square rooting and reciprocals. I want to show you a reciprocal problem. It seems pretty straightforward. Example. One over x is greater than 1 over 3. Solve. in first year algebra, if this were an equal sign, it would be trivially easy. You can do anything you want as long as you do it to both sides, including taking the reciprocal. So if you had like this, you don't have to write this down, but 1 over x equals 1 over 3. I mean, you could probably do it in your head, x is equal to 3. But here's technically what you're doing. Take the reciprocal of both sides. X over 1 equals 3 over 1, which basically means x equals 3. That's relatively easy. But you can do that here, but there's a price to pay. If you did it, it would look like this. If you take the reciprocal, it's x over 1, reciprocals flip the sign, then 3 over 1. So you should get x is less than 3 and you're done. It turns out that's only partially right and partially wrong. Let's see what happens. Whenever you're taking reciprocal type problems, you need to get the answer equal to 0. I'll show you why in about 5 minutes. But can somebody get the answer down to 0 for me? Nick, go for it.
Subtract 1/3.
Subtract 1/3. So 1 over x minus 1 over 3 is, it's going to be 0. Does that flip the sign? Maybe subtract?
No.
No, so it's still going to be greater than. Does that make sense? Add the opposite for me. Can somebody get a common denominator for me? Mary, help me out here. What common denominator would work here?
3x.
3x, yeah. 3x, addition. What is this missing to make 3x? A 3. So times 3 as long as you do it to both sides. So what's the new top?
3.
Good. What is this missing?
X.
An x. What's the new top?
Minus 1x.
Right, negative 1x. And now we can add these up. It's going to be negative 1x plus 3 over 3x greater than 0. This looks a little different than it started off as. Use plus minus notation now. Are there any roots? Where do you look for roots? Chili.
The top.
In the top. Is the top ever equal to 0?
What is it when it's equal to 0?
In other words, what's the root?
3.
Yeah, it should be equal to 3 when you subtract. 3 on both sides. Negative 1x equals negative 3. Sure enough. Divide by negative 1. X equals 3. So there is a root at x equals 3. Any other object anybody sees? I got a root from the top. Good.
An asymptote at 0.
There's a vertical asymptote at x equals 0. Correct. These are both single root, single vertical asymptote. Now we can do plus minus notation. So there's a mark at 0 and a mark at 3. Vertical asymptote at 0, single root at 3. And I've got 3 regions, A, B, C. Somebody run the plus minus notation for me. Josh, help me out. What would you do?
1.
Yeah, 1 sounds good. What region is that? It's region B. So x equals 1. So y is equal to, it's this thing here. So it's something on top, something on the bottom. Plug in a 1 and tell me if the top is positive or negative. Positive. What about the bottom?
Positive.
Also positive. What's the region?
Positive.
Good. Region B is positive. How about region C?
That's negative.
Negative. How about region A?
That's
Also
also negative.
negative. Single asymptote, single root, we'll switch the sign. What regions were we interested in? Nick?
Just be
Positive or negative?
positive.
Positive, because we wanted above 0. So what region are we talking about? Region B. Give me the answer. X belongs to what?
Whenever I hit 0.
Yeah. From 0 to 3, here's what we got with the reciprocals. X is less than 3, which is true up to a point, literally. It stops at 0. It doesn't keep going to negative infinity. Only from 0 to 3. Why? because there was a vertical asymptote that blew up the problem. In other words, instead of going from negative infinity to 3, there's an asymptote that chopped it right in the middle, and now it only goes from 0 to 3. Does that make sense? That's a tricky one. I think there's like one problem in the homework that does that. So anytime you have a reciprocal problem, make sure, don't yield to the temptations to actually do the reciprocal. You will get half the answer, but you won't get the whole thing. You'll have to get the answer to 0, get a common denominator if you have to, and do plus minus notation. That's the only way to get the complete answer. Does that make sense? What I would like y'all to do, oh yeah, I've got to show you one other thing, and then I'll give you some time to work. This is a review from the other year. It's a review on splitting. What in the world is splitting? Solve the following. Try that. Negative 3 times the absolute value of x plus 2, then with a plus 2 outside, all divided by 5, then with a plus 7, is greater than or equal to 2. How would you recommend solving this? Oh, math people. Mary, take this one. Where would you start?
Subtract the 7.
Yes. What method are you using?
Algebra.
Algebra. What allows you to use algebra? Because a lot of these problems you can't. If I had done x squared plus 5x plus 4 as the those, couldn't do algebra. Why not? Yeah.
Oh, one species.
Yeah, there's only one species of x. If you have two different powers of x, algebra is dead in the water. This one you got lucky. So I'm sorry, what were we going to get rid of first?
The 7. So
How?
subtract it.
Yeah, is that going to flip the sign?
No.
No, subtraction never does. All right, what do you have so far?
Negative 3 absolute value. X plus 2 absolute value. Plus 2
Okay,
over 5.
over 5.
Is greater than or equal to negative 5.
Good. Still greater than or equal to because it doesn't flip. Josh, take over. Right, multiply by 5. Does that flip the sign? Why not? Right, we're not multiplying by a negative. These will cancel. Don't distribute the 5, by the way. It's just going to die in battle. So negative 3, keep going. Absolute value of plus 2 is negative 25. Good. Sam, take over. Yeah, does that flip the sign? No. Tell me what you have.
Negative 3 absolute value of x plus 2 is greater than or equal to negative 20.
Negative 20.
7.
Good, they join. Do the next one while you're at it.
Divided by negative 3.
Right. Everybody look up here. Please do not distribute the negative 3. It might be tempting, but you can never distribute over absolute values. Never, ever, ever, with an exception that I'll tell you probably at the end of the year. For as far as we're concerned, never distribute over absolute values. I'll explain that more later. But for now, how do you get rid of it? Oh, sorry. Divide by.
Negative 3.
Is that going to flip the sign? Yes. Tell me what you have so far.
So absolute value of x plus 2
Yes.
is less than or equal to
Because in 27.
9.
9 times. Good. The absolute value is still there. A lot of people are tempted to just drop the absolute value signs. You can't. Not until you do what? Okay. How do you actually tear down absolute value? What technique is
Splitting.
splitting? Exactly. Let's see what that looks like. Get rid of this. Splitting an absolute value kind of looks like an upside down goalpost with arrows. X plus 2 absolute value, I'm just going to recopy this. It looks like this. 1 plus, 1 minus. What would go here? Jill.
X plus 2 is less than or equal to 9.
Less than or equal to, correct. Less than or equal to positive 9, and then give me the other one.
X plus 2 is greater than or equal to negative 9.
Correct. Does splitting flip the sign?
On the negative side, it does.
Only on the negative side, correct. And finish it off for me, Becca.
So subtract 2.
Subtract 2. Does that flip the sign?
No.
No. So what do you get?
X is less than or equal to 7.
Can't track it yet, but wow. And then go ahead and do this.
Subtract 2.
Right. Does that flip the sign?
No.
No. So what do you get?
X is greater than or equal to 11.
Negative 11. Good. Can you translate these into interval notation? Anyone? This is the old-fashioned notation, which is fine, but I want it in interval notation. X belongs to. If you get stuck, if you're saying like, I don't know how to do that, I would suggest you draw a number line, graph it. There's a mark at 7 and a mark at negative 11. By the way, you notice the 7 is on the left-hand side and the negative 11 is on the right. That's an accident. Please do not put 7 over here and negative 11 over here. That's embarrassing. But solid dot, which way is this going? Austin. Which way is it shading?
Shading.
Okay, Josh. To the right. X is greater than or equal to negative 11. It's going to go this way. How about 7? Which way? To the left. What ultimately is this going to look like? What happens when you have two that are aiming toward each other like that? What does the final graph look like? Take a hazard guess. Go. They connect them. Correct. All the stuff from negative 11 to 7 and not beyond. Can somebody translate it into interval notation now? Go.
Includes square bracket.
Okay.
Negative 11, comma 7 square bracket.
Exactly. Questions? So 2 things going on here. 1 is a review of how to split absolute values. 2 is a review of what happens when it flips the signs. And 3, it's a little on the tricky side to find out what's the interval notation of this. If there's any doubt, graph it on a number line. Because you might have like 2 or 3 different pieces or something like that. Double check and then do interval notation. Does that make sense? That is all I have for you. So if you want to continue on, tomorrow the worksheet 3A-2 is due. And then Thursday, problems 1 through 31 odd for homework 3A is due. Some of them are very fast, some of them are not quite as fast. So plan ahead. I will tell you right now, one of the longest problems in here is potentially, unless you know the trick, number 9. So you need to find a pretty big common denominator and distribute and blah, blah, blah. I'll let you try that on your own. There is an easier way to do number 9, if you can find it. I nicknamed it the machine gun method way back when. You remember that? I'll give you a little hint. X over 3 plus 1 over 4 plus 2 over 5 equals 6. Or less than or equal to 6. Let's do it. Inequalities. The machine gun method is, let's say you want, normally you'd get a common denominator, and I think you'd use 60 or something like that. It's relatively big. What number holds 3, 4, and 5 at the same time? 15 would be 3 and 5. 20 would be these. It looks like 60 is the smallest one that will still work. The machine gun method is, rather than do common denominator, multiply everything by the common denominator. Just spray it with bullets, so to speak. And these cancel down to 20x. This cancels down to 15. This cancels down to, how many times is 5 go to 60? 12? 12 times 2 is 24, less than or equal to 360. And then you can solve it like normal. Okay? So number 9, you can do that. And that's actually faster than the method they recommended in the reading. Make sense? All right. Rest of the hour is yours. Go to it. People listening at home, God bless you. Hope you recover quickly. Don't get what I got. See ya.